In the yesterday's class, we were at frequency distribution, right? So we'll continue the discussion from the yesterday's section. So what is the meaning of a frequency distribution? So the basic meaning of a frequency distribution is the distribution of the total number of observations to various values or groups. The groups are also called classes. Okay, after having that, next we have is types of frequency distribution. There are two types of frequency distributions we have seen. What are those? Discrete or simple frequency distribution. Second one is grouped or continuous frequency distribution. Those are the two things. So after that, whenever if you go for grouped frequency distribution, that means classes type, some 10 to 20, 20 to 30 like that, different values you combine together and form a group. In that case, each group has two limits. One is called lower limit, one is called upper limit. So those two we know. Okay. So that is called the group which is bounded by two limits is called a class. This classes, how many types I told yesterday? 3 types. What are those? Inclusive type of classes, exclusive type of classes, open-ended classes. Okay. So these are the 3 things we have taken. What is inclusive type? What is inclusive type? Lower and upper limit equivalent values also included in the same class. Exclusive type means lower limit value is included in the class, but upper limit value is not included in the class. It is included in the subsequent class, next forward class. So it is called exclusive type. What is open-ended class? What is open-ended class? Out of the 2 limits, only one limit is specified and the other limit is undefined. Okay, then we call it as open-ended class. Either lower limit is undefined and upper limit defined. Otherwise, lower limit is defined, upper limit undefined. So like that, if you have it, is called open-ended classes. Okay, after having the definition of various types of classes, next we will go with other definitions. Okay, we have a number of definitions associated with the frequency distribution. Okay, so those things one by one we have to see. So the first definition is, what is the meaning of a class interval? Okay, any group of units bounded by 2 limits, we can treat it as classes. Okay, or class interval, a specific range of values relating to a particular characteristic. For example, marks of a student. Okay, you can divide into number of classes: failed class, just passed class, average class, above average class, or what we call extraordinary class, like that. So 0 to 39 is a failed class, 40 to some 60 is average class, 60 to some 75 is a very good class, 85 to some 100 is called extraordinary. So like that we can divide the student performance into different categories or not. So accordingly we can form the classes or not. So 0 to 39, 40 to 59, 60 to 75, 76 to 85 and 86 to some 100, like that. Okay. So those are called class intervals. Okay. A specific range of values relating to a specific characteristic. Okay. So please note down the meanings also. Write the name and meanings also while I am explaining quickly. Just a short point. No need of detailed descripted definition. Okay. So we have a problems on all these type of computations only. Just we have to see after completion of all the definitions. Next definition is class limits. The minimum value which we can include in the class is called lower limit. The maximum value we can include in that particular group is called upper limit. So there are how many limits? 2 limits. Lower limit and upper limit. Lower limit means minimum value we can include. Maximum value we are supposed to include in that particular class. That value is called upper limit. So Class limits. There are two limits, lower limit and upper limit. Lower limit means minimum value. Upper limit means maximum value. If you take an example, that also I have written here. Any example you can have it, just one figure I have given. 11 to 20, one class we have taken. So minimum value we can include in that particular group is 11 only. Maximum value we can include is 20. Therefore 11 is called lower limit, 20 is called upper limit. Just a simple meanings only. So once we have these things, next we have is class boundaries. What is the meaning of a class boundary and what is the difference between the limit and boundary? Okay. Limits means the minimum value we can include and maximum value can be included. Those two are called limits. Boundary means the value up to that the limits can be extended so that the gap between one class to the other class becomes 0. Means one should not have any gap between one class to the other class. Okay, to make that gap to be gap 0, up to what extent value we can extend. So that we have to see. Those values are called boundaries. Extended values of limits ensuring 0 gap between the two successive classes. So with an example we'll see later. Just time being write the meaning and understand it. Minimum and maximum values can be included in the class are called limits. Limits sometimes we need to extend, okay, up to some point so that the gap between one class to the other class becomes 0. So that extended value is called boundary. Okay, how to extend we'll see. For example, here itself we'll see. Or otherwise we'll see later. Now the next is class width. Class width means interval gap, that is called width. Okay. So how to find the width? Width is not the difference between the limits. It is difference between the boundaries only, not the limits. Okay. It is difference between the boundaries. Upper boundary minus lower boundary. The difference is called width. So we can have another name also for this. Width we can say class width or class size. You can write all the names also. Difference between the two boundaries, upper boundary and lower boundary, is called class width. It is also called class length, or it is also called class size. All the names are same. Width, size or length, all the three names are same. Please note down that. Any terminology you can have it in the exam. Class length, class width, class size. Next one is called midpoint. It is also called class mark, another name. Midpoint or class mark. Midpoint or class mark. Formula is average of the lower and upper limits or lower or upper boundaries. Both we can say. Lower and upper limits average. Average means how to find average? Add all the both values and divided by 2. Means lower limit plus upper limit by 2, you can get midpoint. Or lower boundary plus upper boundary by 2. Anything we can say. Okay? Lower limit plus upper limit by 2 or lower boundary plus upper boundary by 2. Okay, that is called calculation of average of the limits or average of boundaries. So then you are going to get mid value of the selected group, exactly center point of that particular group. For example, 10 to 20 we have. What is the middle value? 10 to 20, what is the middle position? 15. Yes or no? Directly we can observe it, but actually computational procedure is lower limit 10, upper limit 20, 10 plus 20, 30, 30 by 2, 15. So like that you have to get it. This is called a midpoint. Another name is also called, it is also called class mark. Note down that also. Midpoint, class mark, both are same. Why we have to take midpoint and all in the coming sections we'll discuss. But all these definitions, meanings, computational procedure we have to keep in mind. So once we have these things, next we have few more definitions. One is called tally mark. This already we know. What is a tally mark? A vertical bar we are using, right or not, in the frequency distribution. A vertical line is used to represent the value of the collected observations, okay, matches with the specific group or a value. Okay, then we call it as tally mark. An identification mark used to represent, okay, that a particular observation belongs to a specific group or specific class or specific value, anything you can call. Okay, this vertical one, this mark is called tally mark. Suppose if one observation is there, we have to put one line. If two observations are there in that particular group, then put 2, then 3, 4, like that. Next, frequency. How many number of tally marks are there against each and every group that you counted? That means total number of observations belongs to a particular group is indicated by frequency. Generally letter F will be used, meaning is frequency. Number of observations belongs to a specific class is called frequency of that particular class. Frequency. Okay? Let's note down these meanings clearly, because as it is definitions also they'll ask number of times. Number of observations belongs to a specific class is called frequency. Next definition is frequency density, or it is also called sometimes class density. Okay. So the frequency density definition, directly write this formula, that's enough. Frequency density means how many observations are in that particular class that you see, that is called a frequency of the class, right? That one divided with the class width, size of the class. Class frequency by size of the class. Okay. This value represents the weightage of preference of that particular class. Okay, occupancy ratio it is. For example, this room is 40 students capacity room. Maximum 40 students we can accommodate in a room. So they can sit. But presently how many are there? Only 14 are there. Actual frequency 14. But size of the class is 40. So 14 by 40 if you divide, then you can get the value, occupancy ratio or not. 14 by 40 how much? Okay, some 31-32% roughly. Okay, 31-32%. Means in the entire classroom size, only 32% only occupied by the students. Means the remaining 68% vacant or not. So like that you can get a complete meaning by using this calculation. Okay, size of the class in the denominator. How many observations are there in that particular class? It is called frequency of that class. Frequency of the class by class size or class width. This ratio is called class density or simply frequency density. Anything we can call. No problem at all. All the definitions are very, very significant in problem solving as well as theoretical questions also. Only formula note down, that's enough. Complete meaning you can get it, sentence also. Next we have completed. Relative frequency. Relative frequency means among the total number of observations, okay, particular class contribution how much. So that is indicated by relative frequency. Specific class frequency by total frequency, total number of observations. Class frequency by total frequency, this is the formula. Suppose, assume some example, simple way. So our institution only you take. So our institution has 150 members. Okay, overall strength. Out of that, this particular classroom's weightage, how much in that? Okay, so we have a 15 members. Total 150. So 15 is this particular class strength. Total strength is 150. So 15 by 150. 1 by 10 means 0.1 means 10% only foundation students, that's all. Okay, remaining 90% are intermediate and final students. Yes or no? Like that you can have the idea or not by having this calculation. So that specific class weightage or priority in the total data, how much, if you want to know. Relative frequency we supposed to calculate. Meaning is that. So therefore class frequency by total frequency is our formula here, right? So total frequency means all the classes frequency total. Yes or no? So therefore denominator value generally more value or not. So numerator we take only specific class frequency only. Therefore numerator is the lesser quantity, denominator is the more quantity we have. Therefore numerator less quantity, denominator more quantity we have. Therefore you are going to get compulsory a fraction or not. Yes, that means between 0 to 1 only you can get value. Yes, each relative frequency value lies between 0 to 1. Even exactly 0 also not allowed, exactly 1 also not allowed. When do you get 0? If the numerator is 0. The numerator is 0 means particular class frequency should be 0. But is it possible to have class frequency 0? If no item is there in the class, no need to specify that class, no, unnecessary, isn't it or not? Therefore frequency 0 not possible. Therefore no chance of getting 0 value. Next, sum of all the class frequencies is nothing but the total frequency. So no particular class frequency becomes total class frequency. So therefore numerator and denominator equality also no chance. Therefore exactly 1 also not possible. Relative frequency always lies between 0 to 1 only. 0 not allowed, 1 not allowed. In between only we are going to have each value. Okay. But if you divide all, if you add all the values, all the relative frequencies, total exactly 1 we should get. That is the meaning. Just now example I have given. Out of 150 members, this class weightage is 15 students only. So 15 by 150 means 1 by 10. 1 by 10 means 0.1. 0.1 means if you multiply with 100, it is a 10%. Yes or no? 0.1 you are getting this class weightage. However, remaining 0.9, the weightage is for other section or not? So that is 0.9, this is 0.1. Total added to 1 or not exactly. So you will get exactly 1. So this is called relative frequency meaning. Okay, definition try to understand, ma. Okay, what meaning you can get it by doing that particular calculation. So meaning try to understand. Computation is a very simple, something by something, anyway calculators are there one can do. Okay, that is not the matter. It's a mechanical job. Okay. So now the next definition we have is percentage frequency. There is no much difference at all between the relative frequency and percentage frequency. The above related frequency obtained, no? That one if you multiply with 100, it will be converted to percentage. Why we are converting into percentage separately, sir? Because percentage terminology is more comfortable to understand the meaning or not. So that's why. In the previous example, this group contribution 0.1 is given. 0.1 means meaning easily, not that much simple way to understand. So if you multiply with 100, it is called 10%. So 10% occupied by this class, 90% occupied by other class. So it is easy or not to understand the meaning. So therefore, we are expressing relative frequency into percentage format by multiplying with 100. Into 100 is there, here 100 is somewhere missing. Okay, compulsory here multiplied with 100 is there here. After the ratio into 100 required. It disappeared here while making the things. Okay, into 100 is there. Write down that. Okay. To take a simple example, just now I told already, here I have written one thing. If a class has frequency 4 out of the total 10 observations, then what is the relative frequency? Class frequency by total frequency, 4 by 10, 0.4. Percentage frequency may multiply with 100. Means 40% occupied by that particular class. Like that. Now converting inclusive type into exclusive type of classes, how to convert? This is nothing but getting class limits into class boundaries. What is class limit and boundary I told? Minimum and maximum values can be included in the group are called class limits. Class boundaries means the limits can be extended to a particular point so that the gap between one class to the other class becomes 0. No gap. So up to what point we supposed to extend to get the 0 difference between one class to the other class? That extended point is called boundary. So how to do this? This is only called converting inclusive classes into exclusive type. Okay? What it is? Simple rule is, first take the classes. Suppose if you have a gap between one class to the other class, okay, then what you do is take the difference. Let it be D. Assume some difference D. Okay, one class to the other class difference D you take. Then make it half. If difference 1 is there, 0.5, 0.5. If difference 5 is there, 2.5, 2.5. If difference 2 is there, 1, 1. Like that. Make it half the difference. There is no rule that the difference always 1 only. Don't take in that way. So maybe difference anything. Okay, one class to the other class difference you take. How to take the difference? Upper limit of one class and lower limit of the next class. The difference only gap is only called difference. Okay, take it. Make that as half. Then from the lower limit subtract half d by 2. For upper limit add d by 2. Okay, then both sides some extension will be there or not? So 10 and 20 we have ma. Next class started from 21. The 20 and 21 gap 1 is there, no? You make it half, means 0.5, 0.5. For the lower limit 10 subtract 0.5, you will get 9.5. For upper limit 20 you add 0.5, it becomes 20.5. So 9.5 to 20.5 becomes the boundaries. Okay. After doing that only boundaries you have to decide, not blindly. Okay. The formula is this. To convert inclusive classes to exclusive classes, first determine the D, the difference between the two consecutive limits. Then the value helps to establish the precise boundaries. What is the boundary? Lower boundary if you want, lower limit minus the d by 2. Upper boundary means upper limit plus d by 2. That's all. Okay, this formula note down. Conversion of inclusive type into exclusive type. Only this formula. Meaning I already explained. So you have the clear meanings further in the material also. No issue. Only formula note down. Time being. D is the difference between one class to the other class. Then write these formulas. Lower limit minus d by 2 is the lower boundary. Upper limit plus d by 2 is the upper boundary. Now we'll see the example. Between one class to the other class. If you see, just take this example. If you want, note down this. Consider the inclusive cases 10 to 20, 21 to 31, 32 to 42 like. This example observe once more. Okay, I have taken the classes 10 to 20, 21 to 31, 32 to 42. Upper limit of one class is same as the lower limit of the next class, huh? No. Difference is there or not? Here 20 is the upper limit, but next class lower limit 21. Gap is there or not? Yes, it is there. Similarly here also. 31 is the upper limit, but next class lower limit is 32. Gap is there or not? Yes. So this gap you find, that gap only D. What is that gap? Here 20 is there, here 21 started. 1 is the difference. Next class also check it. Here 31 is there. Okay. Upper limit 31 is there. Next lower limit is 32. Again 1 only gap or not? Yes. One class to the other class gap is 1. So that is D value is 1. Is it clear or not? D value 1. Once we have the D value, make it half. D by 2 you find. 1 by 2. 1 by 2 means 0.5. Yes or no? After getting that lower boundary I want. So what you have to do? Lower for a first class. For example, 10 to 20 class I want to find boundaries. 10 to 20 class. 10 is the lower limit, no? From that D by 2 subtract. 0.5 subtract. 10 minus 0.5? 9.5. Upper limit is 20 for that particular class. 20 plus D by 2. 20.5. So 9.5, 20.5 are lower boundary and upper boundaries. Limits are 10 and 20 for a particular class. Are you getting or not? Both sides 0.5 extended or not? So that extended point is nothing but boundary. Meaning is, okay na? So if you want, note down example, anything for reference purpose. Anyway, while doing the exercise in the next class, we'll come across number of problems on this type of calculations. First concepts introduction should be clear. Okay. Now the next. Next we go with the class boundaries and number of classes, how to identify. Okay. Using midpoint. Sometimes so they don't give the classes. They'll give midpoints. First class midpoint 15. Second class midpoint 25. A third class midpoint 35. Like that midpoints will be given, not lower limit and upper limits. Okay, midpoints will be given. Then how to find the boundaries? Boundaries are given, how to find midpoint? Lower boundary plus upper boundary by 2. Opposite, reverse. Two midpoints are given. Then take the difference between the two midpoints. What is the difference we have? Okay, find that. That is D assume. Make that as half. Why we are making halves are? Because from midpoint limits we have to calculate, no? Lower limit I have, upper limit I have. So where is the midpoint? In between exactly center or not? So if the difference is D, then D by 2 is nothing but the difference between the limit to the midpoint or not? Half part. So that's why. Difference between the two midpoints you take. That is D. Make it half, D by 2. Then from the midpoint, subtract D by 2. You will get lower limit. For the midpoint, add D by 2. You will going to get upper limit. So like that. Lower boundary and upper boundary meaning. Write this formula. Class boundaries using midpoint. That note down. Class boundary using midpoint. When the midpoints are given, determine D, the difference between two midpoints. After getting that, lower boundary if you want, midpoint minus D by 2. Upper boundary you want, midpoint plus D by 2. So here the simple example. If the midpoints are 15, 25, 35, etc., then between the two successive midpoints, the difference is 10. Okay. So therefore, for the first midpoint 25, if you take first class, midpoint 25, I want the boundaries. Then midpoint minus d by 2, and 10 by 2, 5. So 25 minus 5, 20 is the lower boundary. Upper boundary midpoint 25 plus 5 plus d by 2. So it becomes 30. Therefore, 20 to 30 is the class boundaries. That is the class. Midpoint how much? Exactly center point. 25 is the midpoint. Like that for any class you can calculate. If you want a last class, 35 is there no midpoint. So 35 minus 5 means 30. 35 plus 5, that is 40. Means 30 to 40 is the third class. Like that any class we can determine. Okay, na? The next calculation is class width, how to determine. Class width. Okay, already we have taken in the middle. Okay, in the starting. What is the class width? Upper boundary minus lower boundary. Difference is called class width. Okay. But some cases, if the class is given, class width means upper boundary minus lower boundary. But there is no classes at all. Original data is there with you. Okay. Actual collected data is there with you. Okay. I want to classify into number of classes type. Classes are not yet formed. If the classes are already there, upper boundary minus lower boundary is called class width. Okay, I am not talking about that. Okay, original data is there with you, entire data. There is no classes system in the collected data. Then, how to classify the collected data into number of classes type so that each class should have some width or not? That's what. How to decide the class width? For that purpose, the rule is first decide how many number of classes you want. Is it clear or not? How many number of classes you want, first decide. That the total data I want to represent, I want to classify into how many groups. If students performance example you take. Okay, failed class, average class, a very good class or extraordinary class. I want to divide into 4 parts only, 4 groups only. Remaining way, the type of study is not related with other way. Therefore, I want these 4 groups only. Therefore, how many classes I have decided? 4 classes only I want, 4 groups only I want. So like that, how many number of groups you want first, classes you want, decide that. Okay. After that, take the total range of the entire data. What is the total range means? Range means maximum value of the entire data set, minimum value of the entire data set. That difference is called range. That range divided with how many classes you want, that number. Then you are going to get the value. That value is called each class width or size. Equally you want to divide. There is no rule that classes should be equal always. చాలా మంది ఏమనుకుంటారంటే డేటా చూడగానే అన్ని ఈక్వల్ 0 to 10, 10 to 20, 20 to 30 అలా ఈక్వల్ ఉండాలనుకుంటారు. దేర్ ఈజ్ నో రూల్ దట్ క్లాసెస్ ఆర్ ఈక్వల్. క్లాసెస్ కెన్ బి అన్ఈక్వల్ విడ్త్ ఆల్సో. ఈక్వల్ విడ్త్ there is no rule. But if you have all the classes equal width, one class to the other class, comparisons becomes very easy. Otherwise, comparison we need to compute few more calculations. Directly comparison we cannot make. That is the only difference. Suppose this class has 20 members now. Okay, so adjacent other class also have 20 members. Size is same both. Width means size is same. There 20 members are there, here 20 members are there. Out of the 20, here suppose 15 members passed in the exam. In the other class, 13 members only passed in the exam. So there 13 number of students passed 13, here 15. 15 is more. Therefore, this class has result better as compared with that class. Like that comment easily we can read or not? Yes. But suppose sizes are different. This class has 50 members. Okay. This class has 50 members. Okay. That class has 20 members. Here out of 50, 40 passed. Okay. There out of 20, 20 passed. Okay. Their number of students passed 20. Here number of students passed 40. So here 40 is more. Therefore, this class result is better if you say the comment. If you give the comment, is it correct? Out of 50, 40 passed, at 10 failed. But there out of 20, 20 out of 20 all are passed. That their 100% result is there, here 80% result only we have, isn't it or not? So that means in that situations to compare, what you have to do? Directly value comparison is enough, or by taking the size of the class also into consideration, we have to compute the percentage separately or not? That's the problem. So because of all these difficulties, generally, if possibility is there, we'll try to take equal width classes. But there is no rule like that. According to our study into consideration, or our objective or nature of study into consideration, okay, we can divide into any sizes. All the classes need not be of equal width. Is the point clear or not? That's what. Okay. Suppose equal width classes you want. Formula is this. Calculation of class width formula. Maximum value minus minimum value difference in the numerator by number of classes. Write this formula. Okay, na? If you do like this, all the classes equal width only you are going to get. Unequal width we want, this formula we cannot apply. All equal size if you want, okay. Next one. Completed up. The example is this. For example, the data is ranges from 10 to 91. Minimum value 10 we have, maximum value 91. In between so many observations are there, it doesn't matter. Maximum value, minimum value observe. Then how many classes you want, that you decide. Okay, then the range difference, maximum minus minimum difference, how much? 91 minus 10. So 81. How many classes I want? 4 classes. Therefore total range 81 divided by 4. So approximately you are going to get something 20.25 here. So if any fractional value of part also involved in the obtained answer, then round off to nearest integer. 20.25 means nearest integer is 20 only or not. So roughly select each class size of 20 width. So like that. If it is 20.7, 20.8 like that if you take, if you get, then you take it as round off nearby 21 is the interval. So like that. Because the interval cannot be a fractional value. Okay. Decimal portion is not allowed. If that is allowed, so then the framing the classes becomes very hard. So that's why. Compulsory integer number only acceptable. Next we have a concept called number of classes. Previously classes if we have, size how much we have decided. Here, so how many classes we have to take while constructing the frequency distribution or while classifying the total set of observations into number of classes type, how many we want. This is not a fixed rule actually, an approximate idea formation purpose. So according to my own requirement, I can decide how many classes I want. Okay, that's all. There is no fixed rule like that for data handling or size handling. Okay, but this is one of the formula we have where so we can get approximately a suitable number of classes which are not too less or not too large. If very less number of classes you take, what happens? Only less number of classes you take, what happens? Most of the information will be combined together in a single group. So detailedly if you want the information you cannot. For example, I'll divide the number of students into 2 groups according to their marks. 1 to 50, one group. Now, how many students got marks between 1 and 0 and 250. Next group is 51 to 100. Like the 2 groups I have divided. Now further in my analysis, I want to determine how many students failed. That information I want. Can you get it? 0 to 50, how many are there? Okay, 51 to 100, how many? 2 groups only I have. I want how many students failed. I want to determine that value by doing some calculations on that particular data. So Now, to decide the student is failed or passed, what is the criteria? 40 is the minimum mark, right? 40. If the student managed to score 40, treated as passed candidate, or below 40 means failed. But in our group, what data we have? 0 to 50, how many are there is there? 51 to 100, how many are there is there? But 0 to 39, how many are there is there in your classification? Not there. Now, can you find the data then? How many students failed? Or how many students passed I want? Can you get it? No, 40 onwards passed. But 40 to 50 combined in a single group. Out of that number, how many are there between 0 to 39? How many are there from 40 to 50? That classification division is not there, right? So then how to identify then how many students passed or how many students failed? Can you give the answer? Can you give the answer? Proportionate is not. Frequency distribution is you want accurate value. Is it possible? That's the problem. Okay. Therefore, classes not too small, 2-3 classes type one should not take. More detailedly, I want the data information, sir. So therefore, I will take some 20 classes, 30 classes like. Then the table becomes very large. Why we are going for frequency distribution construction? If the data size is very large, to condense the data, to reduce the data size only, we are going for frequency distribution construction. Yes or no? That's what yesterday we have seen. Okay. If the number of classes, again, if you include number of classes, what is the benefit, sir? There is no benefit at all. Isn't it or not? Our purpose will be fulfilled. No. So therefore, the classes, number of classes, we have to decide based on a criteria that the number of classes not too large, not too less or small. A moderately sufficient number of classes required. So that is essential. That one roughly how to decide. This is the formula. The number of classes formula. 1 plus 3.322 into log n. N capital N stands for total observations. How many are there? Capital N means total frequency. That is total number of observations. Write this formula. Number of classes. 1 plus 3.322 into log n. Here for the logarithm base is not specified. The base is not specified. What is the log value? What is the base? 10. Logarithm calculated with base 10, then it is called common logarithm. If the base is not specified, by default you have to understand the base is 10. This is the formula. So according to the number of observations, we can decide roughly. After getting the value with this formula also, no need to take exactly that many number of classes only. 1 or 2 classes here and there you can adjust also. No problem. Okay. So if you take an example, suppose I have total 10 observations in my data. Okay. Then how many classes are approximately suitable? Okay, that I want to decide. Then use this formula. 1 plus 3.322 into log n. My n is 10. Total 10 observations are there. Okay. Then log 10. What is the log 10? 1. Log 10 is 1. 1 into 3.322 means 3.322. And plus 1. Okay. 4.322. 4.322 means approximately round off. Number of classes compulsory and integer number. No chance of having fractional value. Okay, either 4 classes. One more class if you add, it becomes 5. 4.5 class, 4.2 classes is meaningless. So compulsory integer number required. Therefore, after getting the calculation, round off to nearest integer number. So that is important. So taking 4 classes is meaningful. From 0 to 2 or 0 to 2 or 2 to some 4 or 2 to 5, 5 to some 8 or 8 to some 10. Like that 4 classes approximately you take. It is handy in size. Okay. So that's all. Suppose if you have a number of observations little bit more. For example, take another case. N is equal to 100 you take, for example. 100. Okay. Then what is the formula? 1 plus 3.322 into log 100. N is 100 here. Log 100. Log 100 means 2. 100 means how much? 10 square. Yes or no? What is logarithm? What is logarithm? Any number, if we express in an exponent form, okay, exponent form. Okay, exponent contains 2 parts. One is the base, another one is called power. The The power value is called logarithm. Okay, base is 10. ఇక్కడ బేస్ నాట్ స్పెసిఫైడ్ అంటే మీనింగ్ ఏంటంటే బేస్ బై డిఫాల్ట్ 10. సో ఇప్పుడు మన నంబర్ ఈజ్ 100 ఈజ్ దేర్. సో టు గెట్ 100 విత్ బేస్ 10 ఎలా రాయాలి అంటే 10 పవర్ 2 ఈజ్ నథింగ్ బట్ 100. బేస్ ఈజ్ 10 అంటే పవర్ హౌ మచ్ 2 అంటే లాగ్ వాల్యూ 2 ఫర్ 100. మీనింగ్ ఈజ్ దట్. ఓకే, సో no need to have all these things. We'll have a shortcut procedures to calculate the logarithm in the ordinary calculator. And one more, if anybody is using scientific calculators, that is not allowed. మీరు క్లాస్కి కూడా ఆర్డినరీ క్యాలిక్యులేటరే తెచ్చుకోవాలి. దాని మీదే మీకు ప్రాక్టీస్ ఉండాలి, స్పీడ్ ఉండాలి. ఓకే, దట్ ఈస్ వెరీ వెరీ ఇంపార్టెంట్. సైంటిఫిక్ ఈజ్ నాట్ అలౌడ్. ఆర్డినరీ క్యాలిక్యులేటర్ ఫర్ ద ఎగ్జామినేషన్ ఇట్ ఈస్ అలౌడ్. ఈవెన్ అవర్ మ్యాథమెటిక్స్ ఎగ్జామ్ ఆల్సో ఇట్ ఈస్ అలౌడ్. ఓకే, సో గెట్ ద ప్రాక్టీస్ ఆన్ దట్ ఓన్లీ. ఫాస్ట్గా మూవ్ చేయడం ఎలా చేయాలని. ఈవెన్ లాగరిథమ్స్ అండ్ ఆల్సో డైరెక్ట్లీ యూ కెన్ గెట్ ఇట్ ఇన్ ద ఆర్డినరీ క్యాలిక్యులేటర్ బై యూజింగ్ సమ్ ప్రొసీజర్స్. అవన్నీ కూడా ఏంటంటే మీకు at the time of discussing logarithm topic in mathematics and all, your mathematics teacher will going to teach you. Otherwise, wherever is necessary for us, I will going to teach. Okay, no problem at all. Ordinary calculator ఎట్లా కనుక్కోవాలనే దానికి రూల్ ఉంటుంది. సింపుల్ రూల్. ఆ రూల్ చేస్తే వస్తుంది. మీ దగ్గర క్యాలిక్యులేటర్స్ ఉన్నాయా? యూ హ్యావా? జస్ట్ ఓపెన్ వన్స్ ఆర్డినరీ క్యాలిక్యులేటర్స్. ఓకే, ఇఫ్ యూ హ్యావ్. ఓకే, సైంటిఫిక్ నాట్ అలౌడ్. దట్స్ వాట్ ఐమ్ టెల్లింగ్. అందులో అన్నీ వస్తాయి నీకు. డిఫరెన్షియేషన్ వస్తుంది, ఇంటిగ్రేషన్, ఎవ్రీథింగ్ యూ కెన్ గెట్ ఇట్. దట్ ఈస్ నాట్ అలౌడ్. Okay, ordinary calculator I'm telling, if anybody is having, just check it once. Okay, so the known value only will take, it is convenient. Okay, known value only will take 100 only you take. 100 ki logarithm enta ante with base 10 2. Okay, so with the procedure you can have it. First, for what number you want logarithm, that number you type. For 100 I want logarithm, so type 100 first. Okay, then press root symbol 13 times. 1 3 13 times root symbol 1 2 3. carefully count. మిస్టేక్ వచ్చింది అనుకో మొత్తం పోతుంది. బీ కేర్ఫుల్. ఓకే, 13 టైమ్స్. ఓకే, 13 టైమ్స్. తర్వాత మేక్ ఇట్ -1. ఓకే, ద ఇంటూ 3558. 3558 మల్టిప్లై విత్ 3508. 3558 ఈక్వల్ టు కొట్టు. ఎంత వచ్చింది? 0001. ఆల్మోస్ట్ రౌండ్ ఆఫ్ ఫిగర్ నియర్ బై 2 వచ్చేస్తుంది కాన్సెప్ట్. మన క్యాలిక్యులేషన్స్లో డెసిమల్ పోర్షన్స్ 0.001 సంథింగ్ డస్ నాట్ మేక్ మచ్ డిఫరెన్స్ ఇన్ ద ఫైనల్ క్యాలిక్యులేషన్. అప్రాక్సిమేట్లీ 2 యూ కెన్ గెట్ ఇట్. దిస్ ఇస్ ద వే. ఎనీ నంబర్ యూ కెన్ టైప్. బేస్డ్ ఇన్ క్యాలిక్యులేషన్ యూ కెన్ గెట్ ఫ్రమ్ ద ఆర్డినరీ క్యాలిక్యులేటర్. ఈవెన్ ఇన్ అవర్ మెటీరియల్ బుక్స్ ఆల్సో. ఎనీబడి హ్యావ్ రిసీవ్డ్ మెటీరియల్? నో. ఓల్డ్ వన్. ఓల్డ్ మెటీరియల్ ఇఫ్ ఇట్ ఈస్ నాట్ దేర్ క్లియర్లీ, దట్ ఈస్ అ ఓల్డ్ వన్. ఓకే, so you people will going to get a new material. So there in the beginning I have given all these procedures clearly in the material, so you no need to write also even. So in the material copy, in the beginning, starting prerequisites for mathematical computations, I have included all these steps. Clearly you can have it. Okay, so like that you can get. So here you get a log 100 means 2 into 3.22 multiply, then plus 1 you add it, you'll get 7.6 something. So nearby integer number is 8. So approximately take 8 classes. Or you don't take 20-25 classes, or don't stick on to 2-3 classes. So moderately suitable number is essential. Is it clear or not? So in statistical analysis particularly, the moderate number is very essential. Don't stick on to a fixed value. Okay? Close that. After that chuskochu. First try to attend here. Okay? So don't stick on to a fixed number. The main difference between mathematics and statistics is, mathematics the rules are fixed. In statistics rules are not fixed. Okay, the main baseline you have to follow, but based on the case, based on the situation, you can slightly adjust that also. Is it clear? Suppose you want to assess one teacher's performance. Okay, one person wants to assess the student's performance, so teacher's performance otherwise. Okay, how to assess? Just half an hour demo or 1 hour if you attend the teacher's lecture, and accordingly, so you decide teacher is good or teacher is not good. Is it correct? Highly impossible. What do you get within the half an hour of demo class? Really? In any institutions, if you observe colleges or institutions and all, if any new teacher comes, okay, some demo class will be conducted. After completion of the demo class, okay, the people will come with some slips, feedback slips. Okay, then you're supposed to fill that feedback slips. So based on your information, they'll decide whether this teacher seems to be good or not, whether to appoint or not. Yes or no? So based on the data collection only, they are deciding or not to appoint or not to appoint. This is the statistical work, pakka. Okay? Right. But within the half an hour, what student can understand? Can observe really ability of the teacher? First of all, tell me. Is it possible? Teacher is not good under. ఏంటి అంటే టీచర్ సరిగ్గా చెప్పరావట్లే అంట. ఓకే, ఫస్ట్ టైం యూ ఆర్ మీటింగ్ విత్ అ న్యూ పర్సన్. Okay, his skill is different, his standard is different, his level is different. Okay, he has number of methods of presentation. Okay, he knows. Okay, but you have a limited knowledge and first of all zero in that particular subject. How can you decide whether that fellow is teaching correct or wrong? Tell me first. Is it true? Lot of points we have to check it, right? But within the half an hour, not possible. What you have to do? Ask that new candidate to take at least 5-6 demo classes, not one class. Okay. And you assign the lessons. Assign one lesson which is very basic introductory level lesson. Okay, give a lesson which is moderately some advanced topic is involved. Give one more topic, okay, which is completely complex. Okay, give one more topic which is completely logically related. Like that, different pattern logic related or complexity related topics, you select randomly 4-5 topics and give 4-5 topics. Ask him to teach one topic one day. Then see elementary topic how he is teaching, logical related topic how he is presenting, complex topic also by minimizing the complexity, easy manner he is in a position to present or not, and compare all 4 days performance. Okay. If suppose similarity is there between all the 4 days, then you can get some idea. So what we can conclude? Yes, the basic introductory level also he taught the similar way. Advanced level topic also by hiding the complexity, simple manner only he has presented. That means he has the ability to convince the things to the students very easy and convenient manner. Therefore, this person really useful for our course. Like that if you decide, then it is meaningful or not. నేను చెప్పిందంతా అనాలిసిస్ వర్క్, ఇంకా మనం అనాలిసిస్ టాపిక్ రాలేదు, ప్రజెంటేషన్ దగ్గరనే ఉన్నాం. ఓకే, సో అక్కడ డేటా ఫిగర్స్ కలెక్ట్ చేసి బేస్డ్ ఆన్ దట్ బిహైండ్ వాట్ ఈస్ గోయింగ్ ఆన్ యూ షుడ్ బి ఇన్ ఎ పొజిషన్ టు అండర్స్టాండ్. దట్ ఈస్ కాల్డ్ స్టాటిస్టికల్ అనాలిసిస్. ఓకే, సో అలా నువ్వు డిసైడ్ చేయాలి. ఇస్ ఇట్ క్లియర్ ఆర్ నాట్? సో ఇక్కడ అప్రాక్సిమేట్గా తీసుకుని ఇప్పుడు 8 వచ్చింది ఇక్కడ. సో ఓన్లీ 8 classes I want to take. It's not like that. You can take 9 or you can take 7 also. But more or less a rough idea purpose. We can use this. But no need to follow this number as it is exactly. Is it clear or not? Right. Next is cumulative frequency. This you have the idea, right? What is cumulative frequency? Cumulative means carry forward. Means not only that particular class frequency you take into consideration. The previous class's frequency also carry to this particular class. Then what is the situation at this particular position? You have to analyze. Is it clear or not? So this is called cumulative nature. Number of places you have a cumulative nature is very, very important. Okay, cumulative means past one also should be added to the present to conclude. Don't conclude something based on that particular value only. If you take my students assessment system, yeah, you people have students assessment system, your intermediate examinations you have recently completed. Okay, so you're about to get your results, right? So ఇప్పుడు intermediate లో ఏం చేస్తున్నారు? Throughout the year whatever you teach, okay, just at the end of the academic year only they are conducting one exam, right or not? So based on that one examination, student is good, not good, he is having the ability, not having the ability, so he is eligible to forward to the next level or not, everything is deciding. Is it the correct way? రియల్లీ స్టూడెంట్ నాలెడ్జ్ ఏంటి, వాడి వర్క్ ఏంటి, వాడి నేచర్ ఏంటి, సో అనేది మనం అసెస్ చేయాలంటే దట్ ఈస్ నాట్ ద వే. ఓన్లీ బేస్డ్ ఆన్ వన్ వాల్యూ. వాట్ యూ హ్యావ్ టు డూ? కంటిన్యూస్లీ హౌ టు అసెస్. ఓకే, యూ కండక్ట్ క్విజెస్, యూ కండక్ట్ యూనిట్ టెస్ట్స్, యూ కండక్ట్ వాట్ వి కాల్ సెమిస్టర్ వైజ్ ఎగ్జామినేషన్స్, యూ కండక్ట్ ఇంటర్నల్ ఎగ్జామినేషన్స్, యూ కండక్ట్ మైనర్స్, దెన్ ఫైనల్లీ గో ఫర్ మేజర్. మేజర్ అంటే ఫైనల్ ఎగ్జామ్. ఓకే, ఇవన్నీ కానీ అసెస్మెంట్ చేయాలి కంప్లీట్గా. అన్నిట్లలో క్యుములేటివ్గా రావాలి కరెక్ట్గా. అన్నీ కలిపి యాడ్ చేసి ఓవరాల్ పర్ఫార్మెన్స్ ఈస్ త్రూ అవుట్ ద ఇయర్ క్యాండిడేట్స్ బిహేవియర్ అండ్ నాలెడ్జ్ అసెస్మెంట్ ఈజ్ పాసిబుల్. ఇప్పుడు నువ్వు 1 year మొత్తం ఏం చదవకుండా జస్ట్ ఒక 14 ఇంపార్టెంట్ క్వశ్చన్స్ ఇఫ్ యూ రీడ్ అండ్ గో టు ద ఎగ్జామ్, Okay, accidentally whatever you read, those only is there in the examination, suppose question paper, you can easily get 90. And what నువ్వేం కంక్లూడ్ చేస్తావు? Is a 90% knowledge candidate in the subject. Actually that fellow has zero knowledge in the subject. Yes or no? అంటే you are giving certificate to wrong person or not? నాలెడ్జ్ లేని వాడికి నాలెడ్జ్ ఉంది అని చెప్పి నువ్వు కంక్లూడ్ చేసి సర్టిఫికేట్ ఇస్తున్నావు. యువర్ అనాలిసిస్ రైట్ ఆర్ రాంగ్? ఎందుకు రాంగ్ అయిందంటే బేస్డ్ ఆన్ 1 or 2 వాల్యూస్ బేస్ మీద డిసైడ్ చేస్తే అట్లనే ఉంటుంది. ఓకే, సో వన్ షుడ్ నాట్ హ్యావ్ లైక్ దట్. సో దిస్ ఈజ్ అ వెరీ వెరీ ఇంపార్టెంట్ ఆస్పెక్ట్. ఓకే, క్యుములేటివ్ అంటే ఏంటంటే ముందున్నవన్నీ కూడా క్యారీ చేసుకుంటూ రావాలి కంటిన్యూషన్. ఆర్ గెటింగ్ ద ఐడియా ఆర్ నాట్? ఇప్పుడు నేను ఫస్ట్ చాప్టర్ అయిపోయింది, సెకండ్ చాప్టర్ చెప్తాను నెక్స్ట్. సో మండే ప్రాబ్లమ్స్ చేసిన తర్వాత ట్యూస్డే నుంచి సెకండ్ చాప్టర్కి వెళ్తాను. సో సెకండ్ చాప్టర్కి వెళ్ళినప్పుడు సో ఫస్ట్ చాప్టర్ అయిపోయింది, సెకండ్ చాప్టర్ నేను ఫ్రెష్గా వింటాను, జీరోతో కూర్చున్నాను అనుకో, యూ కాంట్ అండర్స్టాండ్ ఎనీథింగ్. ఫస్ట్ చాప్టర్ నాలెడ్జ్, టర్మినాలజీ, ఎవ్రీథింగ్ యూ హ్యావ్ టు కీప్ ఇన్ మైండ్ అండ్ ట్రై టు రిసీవ్ ద సెకండ్ చాప్టర్. దెన్ ఓన్లీ యూ కెన్ ఫాలో ద సెకండ్ చాప్టర్ అండ్ యూ కెన్ పర్ఫార్మ్ వెల్ ఇన్ ద సెకండ్ చాప్టర్. ఎస్ ఆర్ వై నాట్? ఎస్ ఆర్ నో? అంటే ప్రీవియస్ టాపిక్ నాలెడ్జ్ని క్యారీ చేసుకుంటూ సెకండ్ చాప్టర్ నేర్చుకోవాలా, సెకండ్ చాప్టర్ మళ్ళీ ఫ్రెష్గా స్టార్ట్ చేయాలి విత్ జీరో లెవెల్. ఎస్, దట్ ఈస్ ద సిగ్నిఫికెన్స్ ఆఫ్ క్యుములేటివ్ నేచర్. నేను మీనింగ్ చెప్పడానికి అలాంటి ఎగ్జాంపుల్ చెప్పాను. ఓకే, సో ఇన్ అవర్ డేటా ఆల్సో సేమ్ థింగ్. సో యూ హ్యావ్ టు క్యారీ. దట్ ఈస్ నథింగ్ బట్ క్యుములేటివ్ ఫ్రీక్వెన్సీ. Frequencies, you get it by adding the previous things also to the present class. Not only that present class frequency only into consideration. So these are mainly two types. One is called less than cumulative frequency. Second one is called more than or greater than cumulative frequency. These things in school level you have studied. Okay, LCF, GCF, Ogilvy curve. Right. So that story. So less than cumulative frequency means for every class frequency, the previous class frequencies you have to add. It is called less than cumulative. Why it is called less than cumulative? Because that cumulative frequency always represents how many observations are there below that particular value. That's why it is called less than. Number of observations less than that particular value, how many are there? That is indicated by less than cumulative frequency. So if you take any value, above that particular value total how many are there? That is indicated by greater than cumulative or more than cumulative frequency. Okay, so that's why cumulatives are divided into two categories. Less than cumulative frequency shows the number of observations less than or equal to a specific value or specific class upper boundary below how many are there. So that is the meaning. To take an example, less than cumulative frequency, how to get? Every frequency, first value 5 is there frequency. Previously any frequency is there? No. This is the first one. So write first 5 as it is. Next, if 5 is there, 5 plus next class 7. 5 plus 7, 12. 12 plus 9, 21. 21 plus 11, 32. Like that from first class to the last class, just add all the frequencies. First to last, you will get the values. These values are called less than cumulative frequencies. But you got 12 only. What is 12 indicates, sir? అంటే ఈ క్లాస్ ఏంటి ఇక్కడ 10 to 20 is the class. For this class what is the upper boundary? 20. The below 20 how many values are there in total? That is indicated by cumulative frequency. ఇప్పుడు below 20 how many are there అంటే 12 are there. How sir? 0 to 10 5, 10 to 20 7. So below 20 from the beginning up to 20 total 12 values are there. This figure directly ఇక్కడ ఉంటుందా లేదా? You can have or not? Right away. ఇప్పుడు ఇక్కడ 21 ఉంది. వాట్ 21 ఇండికేట్స్? ఫ్రమ్ ద బిగినింగ్ టు అప్ టు 30 టోటల్ 21 అబ్జర్వేషన్స్ ఆర్ దేర్. సో దట్ ఈస్ ఇండికేటెడ్ బై LCF. ఇస్ ఇట్ క్లియర్? ఓకే, దిస్ ఈజ్ LCF మీనింగ్. కావాలంటే ఈ మాట రాసుకోండి ఒకటి. LCF represents number of observations below a specific value. If values are given, interval ఇస్తే కనుక బిలో అప్పర్ లిమిట్ హౌ మెనీ ఆర్ దేర్ ఇట్ ఈస్ ఇండికేటెడ్. ఆ ఒక్క పాయింట్ నోట్ చేసుకోండి. కావాలంటే ఎగ్జాంపుల్ కూడా రాసుకోండి. క్విక్లీ top to bottom adding and the first 5 plus 7 12, 12 plus 9 21, 21 plus 11 32. Last value always indicate Last value always indicates total number of observations 32. Already one add చేసి చూసుకో frequency ఎంత 32నే కదా. That only we are adding, no. So this is 32 total frequency. Intermediate you have a mathematics. All of you have mathematics intermediate level. You have studied probability distribution. Okay. Right. Now second one is more than or greater than cumulative frequency. అప్పుడు ఎలా చేయాలి? Last class to the first class reverse direction you add. You get the values automatically. That is the only difference. Shows number of observations greater than or equal to a specific value or number of observations above the lower boundary. How many are there? This is the definition. Note down this. Number of observations greater than or equal to a specific value or greater than or equal to a lower boundary. Classes unte lower boundary, values unte above that value. So how to get this? Reverse direction. Same data only have taken. Okay, classes frequencies are there. Reverse direction. First last class. First one 11. Okay, start with 11. 11 plus this previous next value 9. So 20. 20 plus this 7. 27. 27 plus this 5. 32. So like that. Reverse direction. Adding. Then what this 27 indicates? Ante this class lower boundary what it is? 10 or 20? 10. 10 above how many are there indicated? But 20 undi. 20 ante enti? Ante 20 above how many observations are there? There 32 undi. What is 32? Ante lower limit 0. 0 above total how many are there? 32 are there. Like that you can say. Here are three important points we have to observe. Okay. Same data, just the reverse direction added, that's all. So if the cumulative frequencies are given, directly frequencies is a top to bottom adding is called LCF. Last class to the first class reverse direction adding is called GCF, greater than cumulative frequency, less than cumulative frequency. Sometimes in the exam, they'll give cumulative frequency table, not frequency table. Cumulative frequencies will be given and asked to find a particular class frequency how much. ఇప్పుడు ఇంతకుముందు ఏం చేసాం మనము? If the class frequencies are there, okay, class frequencies ఉంటే cumulative we have calculated. ఇప్పుడు అట్లా కాదు, ఇవి ఇస్తాడు. ఇక్కడ క్లాసెస్ కూడా ఇప్పుడు క్లాసెస్ ఇస్తాడు. He'll give the classes. Then this cumulative frequencies will be given. So based on that, for the second class, what is the frequency? Like that they'll ask. Okay? అలా అడిగినప్పుడు సింపుల్ రూల్ ఏంటంటే ఇప్పుడు చూడండి, ఇప్పుడు 7 కావాలి నాకు. 7 ఎట్లా వస్తుంది సార్? ఇది GCF. 27లో నుంచి ఈ నెక్స్ట్ వాల్యూ 20 సబ్ట్రాక్ట్ చేస్తుంది. 7 విల్ గోయింగ్ టు గెట్ ఆర్ నాట్? దట్స్ ఆల్. సో ఇది ఫార్ములా. LCF అనుకోండి, any class frequency you want to get using LCF, less than cumulative frequency, that class cumulative frequency minus previous class cumulative frequency subtract. That's all. GCF is given, then frequency of a particular class if you want, that class GCF minus next class GCF you have to subtract. You'll get the particular class frequency directly. That is the only thing, just manipulation. Using LCF, using GCF. Write these expressions. ఫ్రీక్వెన్సీ టేబుల్ ఇవ్వగానే బ్లైండ్గా క్యాలిక్యులేట్ చేయదు. వాడు ఇచ్చింది డైరెక్ట్లీ ఫ్రీక్వెన్సీ టేబులా, LCF టేబులా, GCF టేబులా, యూ హ్యావ్ టు అబ్జర్వ్ ఫస్ట్ కేర్ఫుల్లీ. Then only we have to go for computations. Otherwise, everything will go wrong. Okay? And one more important point. Any class boundary you take, any class boundary, data also will show. Any class boundary you take, whether 0 or 20 or 30 or any particular boundary, that boundary is GCF you take, that boundary is LCF you take. GCF and LCF both if you add, you will get total frequency compulsory. Any boundary. This is one of the important rules. Keep property note down. LCF plus GCF of any boundary is nothing but total frequency. కొన్ని క్వశ్చన్స్ అని ఇలా కార్నర్ లెవెల్కి వెళ్ళి అడుగుతాడు. వాడు ఎవ్రీ కార్నర్ పాయింట్ ఈజ్ ఇంపార్టెంట్ ఇన్ డెప్త్. LCF plus GCF of any boundary you take, it is nothing but total frequency. You can check for any boundary in the table. Okay, na? Right. Now we will try to observe these properties here. The same table only I have taken, but both in a single table for convenience purpose I have written. Okay, 0 to 10, 10 to 20, 20 to 30, 30 to 40, like that I have classes. Frequency is also there. LCF and GCF we know, top to bottom adding and reverse direction adding is called LCF and GCF. Now check the above properties. Okay. So suppose 10 to 20, what is the frequency I want? Actually 7. మనకు అది తెలియదు, మనకు ఓన్లీ LCF తెలుసు లేకపోతే GCF తెలుసు. దెన్ హౌ టు డిటర్మైన్ దట్ ఇట్ ఈస్ ద 7. సో దట్ ఈస్ మై అబోవ్ ఫార్ములాస్. ఓకే, సో ఫస్ట్ యూజింగ్ LCF యూ వాంట్ టు క్యాలిక్యులేట్. దెన్ వాట్ ఈస్ ద ఫార్ములా? ఫ్రీక్వెన్సీ ఫార్ములా LCF ఆఫ్ ద కరెంట్ క్లాస్ మైనస్ LCF ఆఫ్ ద ప్రీవియస్ క్లాస్. బట్ ఇప్పుడు నాకు 10 to 20 ఫ్రీక్వెన్సీ ఐ వాంట్. కాబట్టి దట్ క్లాస్ LCF ఈస్ 12, ప్రీవియస్ క్లాస్ LCF ఈస్ 5. 12 minus 5, 7. వచ్చింది ఆ క్లాస్ ఫ్రీక్వెన్సీ 7 ఆర్ నాట్? Like that for any class you can check it. Okay, similarly GCF also you can verify. For example, I want the frequency of 20 to 30 class. Okay, GCF using GCF how much? 20. Next class GCF how much? 11. 20 minus 11 how much? 9. 9 only the frequency or not? That class minus next class GCF gives frequency. If LCF is there, that LCF and previous class LCF difference gives frequency. These are the first two formulae. Okay. Now the third one is, look at this property verification. Any limit you take. Which one will take? Any number. 20 you will take? Check 20 first. Okay. 20 is the boundary I am taking. Means for one class 20 acts as a upper boundary. For one class 20 acts as a that you have to keep in mind. Okay. Look at here, for which class 20 upper bound? E class. Right or no? 20 is the upper boundary for this class. Yes or no? Upper boundary below values LCF or GCF? Upper boundary below, how many values are there? Indicated by LCF or GCF? LCF less than cumulative. Below ane daniki less than cumulative. Above ante greater than or more than cumulative frequency. ఇప్పుడు అప్పర్ బౌండరీ తీసుకున్నప్పుడు దీనికి అబోవ్ అని మాట్లాడాలనుకున్నది. ఎందుకంటే అక్కడికి ఎండ్ క్లాసే అక్కడికి ఎండ్ అయింది కదా, దాని పైన ఎన్ని ఉంటాయంటే 0 ఉంటాయి. ఎస్, అది మీనింగ్. బట్ అలా తీసుకోవద్దు. సో అప్పర్ బౌండరీ తీసుకుందామంటే LCF చూడాలి. నౌ హియర్ 20 is the upper bound. What is LCF? 12, right. Next, same 20 becomes a lower boundary for next class or not? Yes, in this class it is a lower boundary. Whenever it is a lower boundary type you have, then look at GCF. What is the GCF? What is the LCF here? 12. 20 plus 12 total how much? 32. Total frequency 32 only or not? Adding all these values. Yes. ఏదైనా చూస్తే చెక్ చేయండి కావాలంటే. Shall we take 10? ఇక్కడ అప్పర్ బౌండరీ ఇక్కడ లోవర్ బౌండరీ. అప్పర్ బౌండరీ ఉన్న క్లాస్ ఏమో ఎల్సీఎఫ్ తీసుకోవాలి 5. ఇయర్ లోవర్ బౌండరీ ఇస్ దేర్, దీనికి జీసీఎఫ్ తీసుకోవాలి 27. 5 and 27 టోటల్ హౌ మచ్? అటు ఇటు వచ్చిందా లేదా? ఇది ప్రాపర్టీ మీనింగ్. ఎనీ బౌండరీ ఒక బౌండరీ ఫిక్స్ చేసుకొని దాని అప్పర్ బౌండరీ చూడండి, లోవర్ బౌండరీ చూడండి. అప్పర్ బౌండరీ రిలేటెడ్ ఎల్సీఎఫ్, లోవర్ బౌండరీ రిలేటెడ్ జీసీఎఫ్ యూ టేక్ అండ్ యాడ్ బోత్. కంపల్సరీ టోటల్ ఫ్రీక్వెన్సీ 32 ఓన్లీ విల్ గోయింగ్ టు గెట్. అది ఆ ప్రాబ్లంలో డేటా టోటల్ ఎంత ఉంటే ఆ నెంబర్ వస్తుంది బై డిఫాల్ట్. ఇస్ ఇట్ క్లియర్? ఓకేనా ఎవ్రీబడి? రైట్. కావాలంటే నోట్ చేసుకోండి, ఏదైనా ఎగ్జాంపుల్ తీసుకొని ఇఫ్ యూ వాంట్. టేక్ ఇన్ దిస్ వాల్యూ. Now next we have is graphical representation of data. With that frequency related terminology and everything is over. How many definitions we have introduced? Can anybody list? All the definitions which we have introduced. First, what is the frequency distribution? Then frequency distribution, two types: discrete frequency distribution or grouped frequency distribution. Okay, after that, classes, three types of classes: exclusive type, inclusive type, open-ended type. Okay, after that, so we have frequency related, classes related. So class interval. Okay, so then class limits, in that two categories: lower limit and upper limit. Next, class boundaries, lower boundary and upper boundary. Next, class width also, width or size or length. Okay, that is. So after that, midpoint, lower boundary plus upper boundary by 2 or lower limit plus upper limit by 2, midpoint. So after that, tally mark. Next, frequency. Then frequency density. Next, relative frequency, percentage frequency. Then converting inclusive to exclusive, how to convert, taking the d by 2 and all. Similarly, finding the boundaries by using the midpoint also. Okay, so then class boundary determination. Next, number of classes determination. Yes or no? That formula 1 plus 1 3.322 into log n formula. Those things. After that, cumulative, less than cumulative frequency, more than cumulative frequency. Okay. So of course, based on that, last two formulas also we have listed. Almost 18 to 19 expressions we have taken. All these things you have to keep in mind. Any question from any corner we can expect in the exam. Okay. Now the last section in the first chapter. Okay. Just a little bit introduction I'll give today, because I'll stop at 1 o'clock exactly. I don't take up to 1:30 because I have class in Dilsukh Nagar branch. By 2 o'clock I have to travel all the way. Okay. Sorry, the urgent work has taken early actually my class. Okay. So graphical representation. So frequency distribution we got. Frequency distribution is the actual data na or reduced data na? Reduced condensed form is nothing but frequency distribution, not the collected data as it is, isn't it or not? This frequency distribution, if you represent on the graph, then you're going to get some pictures. Okay, those are called graphical representation. Diagrammatic is different, graphical is different. Okay. Graphical representation means both sides will going to have. Horizontal axis we have a measurement, vertical axis also will going to have measurement. Okay. So graphical representation means the representation of the frequency distributions, okay, on the graph are called graphical representations. Okay, in these graphical representations mainly we have 4 types of representations are very, very important. One is histogram, second one is called frequency polygon, next one is called ogive curve. కొంతమంది దీన్ని ఓజివ్ కర్వ్ అని చదువుతారమ్మా, ఎలా చదివినా ఓకే. ఓకే, కానీ జనరల్గా అయితే ఓగివ్ కర్వ్ ఇస్ ద ప్రాపర్ వర్డ్. చాలామంది రకరకాలుగా చదువుతుంటారు, ఓజివ్ అని చదువుతుంటారు. మీరంతా మ్యాథమెటిక్సే కదా, రైట్? మ్యాథమెటిక్స్లో ఈయన డిఫరెన్షియేషన్ ఐడియా ఉంది కదా. డిఫరెన్షియేషన్, లిమిట్స్ క్యాలిక్యులేషన్. లిమిట్స్ కనుక్కునేటప్పుడు సో సంథింగ్ బై సంథింగ్ ఫామ్ ఉందనుకో, Directly if you put the value 0 by 0 or infinity by infinity వచ్చిందనుకో, so then we'll use some rule. చదివారా? Numerator separately do the differentiation, denominator separately do the differentiation, then you substitute the value to get the limits. దీన్ని ఎల్ హాస్పిటల్స్ రూల్ అంటారు. పేరు చెప్తే గుర్తొస్తుంది, అందుకే చెప్పిన. ఓకే ఓకే దాన్ని ఎల్ హాస్పిటల్స్ రూల్ అంటారు. ఓకే the rule is this. చదివారా ఎవరన్నా? ఎనీబడి ఎవరైనా మాట్లాడారా? చదవలేదా? ఇది మామూలుగా ఉంటుంది లిమిట్స్లలో, ఇంటర్మీడియట్లో చదువుతారు. ఓకే, మరి మీరు చదవలేదంటే నాకు తెలియదు. ఓకే, ఎల్ హాస్పిటల్స్ రూల్ అంటారు దీన్ని. ఇది ఏంటంటే ఎఫ్ ఆఫ్ ఎక్స్ బై జీ ఆఫ్ ఎక్స్ ఫామ్లో ఉండి దీనికి లిమిట్ ఎక్స్టెన్స్ టు సంథింగ్ నువ్వు ఫైండ్ అవుట్ చేయాలనుకో, నువ్వు ఈ వాల్యూ డైరెక్ట్లీ సబ్స్టిట్యూట్ చేసినప్పుడు 0 by 0 ఫామ్ ఆర్ ఇన్ఫినిటీ బై ఇన్ఫినిటీ ఫామ్ ఉంటే సపరేట్లీ డూ ద డిఫరెన్షియేషన్ ఫర్ న్యూమరేటర్, సపరేట్లీ డూ ద డిఫరెన్షియేషన్ ఫర్ డినామినేటర్ చేసిన తర్వాత వాల్యూ సబ్స్టిట్యూట్ చేయాలి. మళ్ళీ 0 by 0 ఆర్ ఇన్ఫినిటీ బై ఇన్ఫినిటీ వచ్చిందో డూ వన్ మోర్ టైం సక్సెసివ్ డిఫరెన్షియేషన్. ఓకే, అలా చేసి నువ్వు లిమిట్ కనుక్కోవచ్చు. ఓకే, ఎందుకు చెప్పారంటే ఓగివ్ అండ్ ఓజివ్ దానికోసం చెప్తున్నా. ఓకే, సో దీన్ని చాలామంది మోస్ట్ ఆఫ్ ద మ్యాథమెటిక్స్ పీపుల్ విల్ రీడ్ దిస్ యాజ్ ఎల్ హాస్పిటల్స్ రూల్. ఈజ్ అ స్పానిష్ సైంటిస్ట్. In their language, S is a silent word. This fellow's name is Mr. L'Hopital, not L Hospital. Okay, every mathematician made him as a hospital. Okay, his name is LHO L'Hopital. S is a silent word. Okay, Mr. L'Hopital, one of the famous mathematician. Okay, అలా ఉంటాయి, అందుకని చెప్తున్నా. సో కాబట్టి మై ప్రొనౌన్సియేషన్ ఈజ్ ఓగివ్ కర్, నాట్ ఓజివ్ కర్. ఓకే, so accordingly you can pronounce. So these 4 types of curves we have to study. Okay, the properties and all, diagrams and all, drawing is not there, but key points lot of we have to observe here. అది వల్ల నాకు కొంచెం క్లాస్ మిస్ అయింది. ఇంకో 15-20 minutes అయితే అయిపోతుంది యాక్చువల్గా. సో వీ హ్యావ్ స్టార్టెడ్ లేట్. సో ఎనీవే మండే ఒక 20 minutes విల్ డిస్కస్ దోస్ డయాగ్రామ్స్. అది అయిన తర్వాత ప్రాబ్లమ్ సాల్వ్ చేస్తాం. ఇది ఆల్ ద పాయింట్స్ ఓకే, రైట్.